Today we're going to talk about Newton's first law. So, a little history before we start talking about Newton's first law. So, back in the day, and this was around the year 330 BC, this was like 2,350 years ago. Let me say that again 2,350 years ago. It's a long time. So, Aristotle said that the natural state for things in the universe was to come to rest. Now, the reason that people thought this back then was because people always observed objects to come to rest in their everyday life. So, if you think of something like a soccer ball, like in this picture, if you kicked this soccer ball, it would eventually roll to a stop. Okay, this is just what we observe in our everyday life. Now, what they observed is that in order for something to continue its motion, they thought that a constant force had to be applied because they didn't know about things like friction back then. These days, we know that there is a force called friction that will make these things stop, but they didn't know that back then. So they just thought everything just had a natural tendency to come to rest. Now, enter Galileo, and this was in the 1600s. So this was about 2,000 years after this, after Aristotle. So people thought that for a long, 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 long time. And then Galileo came in and he did some experiments. So, what he did was he experimented with these spheres on inclined planes like this. So, he observed that when he released a sphere from this initial position here, that it would roll up to the same height that he released it from. Now, when he decreased the incline a little bit, it would still roll up to the same height. So when he asked himself, well, what would happen if I then didn't have an incline on the other side? If it still rolled up to the same height when I decreased that incline, if there was no incline, it had no height to roll up to. So theoretically, it would just keep on rolling forever and ever and ever. So, what he found was that the nature of an object, the natural state of an object, is to continue its state of motion, whether that be to continue the state of rest or continue its state of actually moving. So he said, no, 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 Aristotle was wrong. Really, it is not the nature of objects to come to rest. It really is the nature of objects that are moving to keep moving. Now, this resistance to a change in motion, so resistance to either keep moving or resistance to a change in a state of just rest, is something that we now call inertia. All right, so the property of objects to resist changes in motion is called inertia. That's really important. So let's talk about this word inertia. The definition of inertia is an object's resistance to a change in its motion. All right, the resistance to a change in an object's motion. So if you guys have watched Bill Nye before, which I'm sure you have, everyone's seen Bill Nye, I feel like. He has a theme song, and most people know the theme song. They talk about inertia in the theme song. Do you guys remember it? So it goes, Bill, 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 Bill. And then there's a woman's voice that says, inertia is a property of matter. So what does Bill Nye teach us in his theme song? That inertia is a property of matter. Now, what is matter exactly? Now, matter is just the amount of stuff that your body's made up of. So the more mass you have, the more matter you have. And really, it's the more matter you have, the more mass you have. So matter and mass are basically interchangeable. Okay. And then the more matter you have, the more mass you have, and therefore the more inertia you have. Okay. So matter equals mass, and it's just the amount of stuff that something is made up of. So the more mass something has, the more inertia it has. All right. And I almost forgot to make my corny joke. So because matter and mass are basically interchangeable and the same thing, we know that you all have mass. We all have mass. And that means that you matter. Aww. My corny physics joke of the day. So the take home here is that the more mass something has, the more inertia it has. It doesn't mean that mass and inertia are the same thing, okay? But just that they're directly proportional. So again, We have inertia is an object's resistance to a change in its motion. So let's talk about what this actually means. Now, if I have a little tiny pebble and I have a big, huge boulder, all right, which one has more inertia? If you said the boulder, you're correct. Okay. The boulder has more mass, right? It's made up of more stuff. It's heavier. It has more mass. It's more massive. So, therefore, it has more inertia, which means it has more resistance to a change in its motion. Now, if both of these things are at rest, I already know that intuitively, right? If I try to kick the pebble, it's just going to just move really easily because it's tiny. It doesn't have a lot of inertia. It doesn't have a lot of resistance to a change in its motion. Now, if I try to move the boulder, on the other hand, it's going to be much, much harder, right? It has a lot of mass. It has a lot of inertia. It has a lot of resistance to a change in its motion. Now, that's when these things are at rest. What if these things are moving? Okay, they're still going to have inertia. They're still going to have a resistance to a change in their motion. If a pebble's moving toward me, I'm not going to be scared because it doesn't have a lot of inertia. It's going to be easy to change its motion. Now, the boulder, on the other hand, is going to be much, much harder to change its motion because it has a lot of inertia. It has a lot of resistance to a change in its motion, which is why Indiana Jones runs from the boulder, right? That boulder has a ton of inertia. There's no way he can turn around and put his arms out and try to stop it because it has a lot of resistance to a change in its motion. And therefore, he either runs or he gets squished. Okay? So, other examples of inertia. There's a ton of examples of inertia, okay? But basically, there's one that's really, really common, and you've probably felt it before. Have you ever been driving in the car, like your mom or dad's driving or whatever, and then they slam on their brakes, right? What happens? You fall forward, okay? It's because you were moving and then the car all of a sudden stops, but your body has inertia. So it has a resistance to a change in its motion. So you keep moving forward. We can actually see this in this video right here. Now, watch what happens when the car stops. Those crash dummies keep moving forward at the same speed the car was going before because they have a resistance to a change in their motion. Okay, so that's just inertia. That's all it is. Another example could be an elevator. Have you ever gotten into an elevator on the ground floor and then you press a button, the doors close, and you start going upwards? What happens? You feel heavier. Now, the reason you feel heavier is because your body has inertia. It wants to stay put where you are. When the elevator starts going up, you're kind of pressed into the floor because your body's resisting that change in the motion. It's resisting you going up. So it wants to stay where you are. So that's why you feel heavier at the bottom. At the very top, when you get to your top floor that you're going to, you feel lighter. Now, the reason you feel lighter is because you're moving up, 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 up. And then again, your body has a resistance to a change in its motion. So it's almost like your body kind of keeps moving up, but the elevator stops. So the floor almost kind of falls out from underneath you a little bit, and therefore you feel lighter. So those are other examples of inertia. Now, let's talk about Newton's first law. Now, Newton's first law, another name for it, is the law of inertia, which is why we're talking so much about inertia. Newton's first law states that an object at rest stays at rest and an object in motion stays in motion unless acted upon by an unbalanced force. Now, we're going to unpack this in a bit, but look at this first part. An object at rest stays at rest, an object in motion stays in motion. So that's exactly what Galileo said. The natural tendency of an object is to continue its state of motion. And that's what we called inertia. Objects have a resistance to a change in motion. So that's why Newton's first law is called the law of inertia. So we're going to unpack this now. So the first part says an object at rest stays at rest and an object in motion stays in motion. So rest stays at rest, motion stays in motion. Now, if we're at rest and we're staying at rest, that means we have no velocity, right? We're not moving. Now, an object in motion stays in motion. This is meaning at constant speed and in the same direction. So what this means is we have a constant velocity. So both when an object stays at rest And when we have a constant velocity, what this tells us is that we have no changes in velocity. When we have no changes in velocity, we have no acceleration. All right. So Newton's first law is kind of when we have no acceleration. The object at rest stays at rest, and an object in motion stays in motion. But now let's look at the second part of this. Okay. The second part says that unless it's acted upon by an unbalanced force, okay, unless it's acted upon by an unbalanced force. So, what this tells us is if an unbalanced force acts on the object, then its state of motion will change. So, either if it's at a velocity of 0 at rest, it's going to start moving. If it's moving, then the velocity will change. So, velocity in either case is going to change. Therefore, that tells us that there will be an acceleration. So the take home here is that if we have an unbalanced force acting on an object, we're going to have an acceleration. So unbalanced forces cause accelerations. That's the take home here. Okay. Now, this is Newton right here, and of course, he's the one that came up with these three laws. So, we're going to start talking about the three laws in the next couple weeks. But he's saying, what are balanced and unbalanced forces? That's the next thing we have to talk about. Okay, we've talked about Newton's first law, but now we have to know what are forces? What does it mean when they're balanced? What does it mean when they're unbalanced? How do we represent these things? How do we calculate these things? So, in order to get into this, first we need to learn how to draw free body diagrams. All right, and I'll abbreviate that FBDs for short. And in the next video, I'm going to show you guys how to draw free body diagrams. All right, so I'll see you in the next one.